Welcome to demonstrating implementation excellence stream of SNOMED CTX for 2022. My name is Alejandro Lopez Osornio. I'm a senior implementation support specialist at SNOMED International, and I will be moderating today's session. All questions will be answered at the conclusion of the presentation. Online attendees, please use the Q&A box to type your questions to the presenter. And on-site attendees, I will be bringing you the microphone for your questions so the online attendees can hear. I'm now pleased to introduce Jørn Jørgensen from the Norwegian Direktoratet For Ehelse, who will be presenting combining pre- and post-coordinated observables for predicates for vital signs. Jørn, please proceed.
Thank you, Alejandro, and thank you for having me here, and thank you for hosting this presentation at this really great venue. I will be speaking about a project where we try to combine both pre- and post-coordinated observables in implementation. But first of all, I would like to just, and we have the clicker. There it is. So I'm just putting up the names of the team responsible for giving me the basis of holding this presentation. So I'm a bit anxious because most of them are here in the room today. And they probably know better than what I should have said during this presentation. I'm not going to name them all, but you can see them over there. So it's a quite extensive team behind both the idea and the practical work with this basis of this presentation.
There's some anxiety with the clicker because it failed.
Yeah, so we're going to have some breaks. This is a very specific use case we started to work with in Norway. The use case was how to convey observations of vital signs in a home visit service in Oslo in Norway. But still creating a model sustainable to communicate across several use cases, both in different areas of healthcare and in different settings of the measurements. So when we started out this, it was fire using SNOMED. That was sort of the predicament up top. But looking at the fire observable, they said, let's use a line code that has heart rate. But we weren't using heart rate, we were using pulse. And pulses and heart rate are slightly different. But even more, they said, well, it's only going to be home care anyway, so we can just use pulse rate. But still, pulse rate measured at home is very different from pulse rate measured at hospital, or pulse rate measured by a man, woman, or a machine, or pulse rate measured on the throat or on your foot. So there's a lot of data around here that gets lost if you only use pulse rate. So we set out to say, okay, can we capture the details without making it impossible for users? One difference could be the difference of device. You could use an oxygen saturation analyzer. You could use a blood pressure device to measure pulse. Or you could use an electrocardiographic monitor and recorder. That, however, would measure heart rate, not necessarily pulse. So it all goes to say devices can be very different when you try to say something about the patient's pulse. And the second is, of course, you can measure this in different ways, as you will see as soon as the clicker starts working. Here we are. Example here is a radial pulse taking. That's what this person is doing. You can also sculpt the direction on the heart, direct on the heart. So there are different methods, all from having, once again, a machine or using my fingers, and it will affect the result. And our concern was, of course, the people saying you can just use pulse rate. Then you would have trends. We get data from different sources, and the trends of how the pulse has evolved will differ very much. You also have a different clinical implication. The pulse on the throat is one implication. If it's gone, that's really bad news. If it's gone when you measure on the foot, it's only slightly bad news. But it could have different implications on what kind of treatment you would prefer to set in place. We have created a demonstrator. I will not be sharing the demonstration itself today, but we have it on our computers. We are able to show it if anyone should be interested. And you will get a nice screenshots very soon. Yep, here it is. So the prototype shows we can put in a patient, This is a subject in the fire observation profile. We can put in a value, which is one of the objects in the fire profile. And then you have the observation itself, where we have put everything into one coded element in fire. As you can see here, there's a drop down, and these are actual expressions collected from Snowstorm, creating this drop down. Some of them are extensive. They're like definition texts. They're like FSNs. They're not supposed to be for the end user. The end user will have a more simple interface. But that's not really a problem. We just need to tell the machine in the home care service, how is this measured? The machine only needs to know how it should code it. The user doesn't have to know what it is. This is for implementation to make sure you gather the right kind of data with the right kind of metadata. The architecture of what we're doing, we're using the authoring platform, of course, to create our content. We're using Snowstorm. We are using both the international managed service Snowstorm, where we create our edition, and we have a local or national Snowstorm, where we both distribute that content and we add on content in the form of reference sets and mappings and these expressions. In this demo or test we did, we also created a Fire Hoppy server. We created a server for CDS hooks, and we are almost getting along, looking a bit on Smart on Fire. So it's all my presentation now is about how to build these. Actually, it's just build this dropdown and make it logical, make it precise. And the first thing was to say, okay, give me all the sentence of heart rate measured at systemic artery. That's pulse, where you measure the heart rate by feeling an artery. And if you give that to Snowstorm, you will find its pulse rate, brachialis pulse rate, dorsalis pedis, posterior tibial, actually just 4 places to measure a pulse, stating nothing about the device used, method, nothing. That's it. We could, of course, expand the hierarchy quite extensively, but that's where we said we're going to need something more. And this is the list we created. It's not extensive. No, it's not complete. That's what I mean. It's not extensive either. You can add on. And this is the first time I'm going to say the words open world and closed world. Because this is, if you pre-coordinate everything, you sort of infer a closed world view on things. You say, these are the things you can choose between. What we set out to do was give us what you have done, and we'll create the expression for you on the fly, and we'll see if it's already there. When you're closer to an open world, you say, if you have a new device, then put that device in. So we created these in the test. And as you see, here are 2 examples that will go through the rest of my presentation. Number 8 here being a measurement of pulse using your fingers and lower on the radialis. And the other one, measuring the pulse by using an oxygen saturation monitor. So one is a method, the other one is a device. Both indicate pulse, but they will have different implications clinically. We could do it the hard way and say, this is how it looks. And my point by showing you this is, for a computer, whether it's a single number or a large string, it really doesn't matter for the device just knowing, hey, I'm a device measuring using an oxygen saturation monitor, so I'm going to send you a string. For instance, number 15, which actually means what it's there now. So I can just tell that machine, you're always going to send this. It only needs to know 1. Or the person going to the home visit, having their tablet, having measured the pulse, they know how I'm going to do it. It's in the manual how I should do it. Maybe you can have a drop down or 2 or 3 alternatives, but in the end, they only need 1. It's the receiving end, it's the analytics, it's how we interpret. That's the system who needs to know how should I think about this pulse. Having the time, I'm going to go very quickly beyond a sidestep to say, when you have all of these expressions, I said you could build them on the fly. In our demo, that means we go down and we choose one thing. It's a pulse. We put in a value. We say, I use this device. I measured at this location, and it builds the expression. That will give you a series of numbers. So what we did is we have a generation of string representation after validation. So we give the expression to Snowstorm. It validates, says, okay, it's a valid expression. I'm going to accept this, and I'm going to store it. But then there is no text. So we created an auto-generators generating a text based on this expression. And of course, as you saw, the texts aren't very human-friendly, but they're definitively humanly understandable. And they're explicit. There is no room for doubt. It's an FSM. It's not according to the editorial policy, but it contains all the elements you need to be properly defined for what this concept is. So that you have validation of these expressions on the fly. You have generation of terms representing the expression also on the fly. That being said, this is not a real-time implementation stage. This is so far what we are talking about design time, because there is a way to go before systems will handle real-time expression creation and validation. So we're making this available, and now we are going into the reference set types. As I said, we have a local Snowstorm. We have a few 10 or 20 national reference sets, something like that. And one of which we are experimenting with now is using the post-coordination expression type reference sets. On the screen now, you will see just a screen dump of how it looks when you query Snowstorm directly. It gives you fields. It gives you the reference component, which is the focus concept, pulse. And then it gives you the expression over here saying, this is the formal definition of what I did. It's pulse doing somewhere, blah, blah, blah. I don't know how to interpret these numbers without a computer. But it really doesn't matter. And it gives you a substrate saying this is working on the International January 2020 edition. If you put in this, you can do some number filtering if you query Snowstorm, even in the browser now using ECL 2.0, you can query and you can get all reference components from the focus ID, and you can get all expressions from the focus ID. We haven't gotten around to putting the texts in there in addition, but I think that's the next step. So being design time, we allow this we allow the concepts to be added to this reference set. And why are we doing this? Because if we're now using ECL 2.0, remember our goal is to have the information element inside a file profile for observables. So first part of our expression here, the red one, is the first I showed you. All descendants of heart rate measured at systemic artery, all pre-coordinated concepts of pulse. That's the first one we're going to get. It's going to give us 4 concepts. This is directly from the browser. Then we go to the next one, which is the red one here. It says, for all descendants of my reference set, the expression reference set, could you please give me all reference component expressions? And Snowstorm actually gives you this list. So if we combine those two, we actually have an intentional ref set gathering all variants of pulse, both pre-coordinated and post-coordinated. And one of the few things we're now struggling with is pulling this through the FHIR APIs. And I just talked to some Snowman International members, staff saying, well, this is Snowstorm 8.0 beta, so we're anxious to go home and install that one. But if we manage to do this, you actually have the first list I showed you available for referencing inside a FHIR profile. And you have your value set that serves different use cases in a fairly simple way, because the computer doesn't need to use everything. or the device out there, but you also have leveraged the ability to do analytics and interpret the results in its proper context. So far we're still in snowstorm up here, and I really need to go over and just go by Happy Fire a little bit, because we also did that. And this is one of the observation profiles. It's a slice. So this is a live link. This will actually work. At least it did last time we tried. It's of course test environment, and test environments are chronically unstable. This is the observation of patient 699658. And it gives you the resource type being an observation, conforming to the fire profile. The ID of the patient, 699658, has a code. Coding, code system LOINC. Here you see the LOINC code, which is a magic value in fire. 8867.4-4 means heart rate. And this is what triggered us in the first place, because this isn't pulse. Don't tell anyone. So, secondary code, systems, name it's info/SET code. And here comes the expression. And display the term we created from our auto-generator, saying this is pulse rate beats per minute, single point in time, using pulse oximeter, which is one of the things I showed you. As I said, it's not your average English, but it's understandable, it's reproducible, and it's unique. Subject, patient. And now I'm going to spend a bit more time on this down here, which says value, quantity, unit, beats per minute. But beats per minute is up here as well. So it occurs 2 times. Now we're into another very interesting issue, which is semantic overlap when you're using the terminology anyway, but at least when you're using expressions. When you're using expressions, you will define content both in the expression and in the model. And this is probably one of the more interesting discussions between fire and SNOMED, and especially when you're using expressions. You could go all terminology and you could say, we really don't need information modeling like fire. We need very, very small information modeling. We need to say, this is an identifier and a code. You don't even need to know the resource types observation, because that's actually given by the focus concept in the expression. But I think that's a bit premature. But this was just to show you also the effect. I mentioned the open and closed worldview. This expression conforms to expression language. So here you can add everything allowed by the concept model, which gives you quite a variety of combinations available. And you don't even need to know them in advance. You can create them on the fly, or at least design time. The fire model information models are more constrictive. They restrict you to what they are able to contain, and you need to go there much sooner. And you, therefore, like for the observation of pulse, you would run the risk of losing elements like pulse oximeter. I think device is okay inside condition, but you will run the risk of losing vital information on the way. We're starting to draw to an end. I know the question should be for the audience. So these are our questions doing this. And I hope you can join in on asking us more questions. One is this data overflow. And I know Caroline was in on something the same. You get so much, there is a lot of noise. Is this noise? I recognize that what you did represents noise in your data set. And a lot of people will say that this is noise. To me, this isn't noise. To me, this is specificity. So actually, this is data overflow. That isn't data overflow, but it's enhancing trust in the data, because when I, as a doctor, receive these measurements, I know that they're coming from pulse oximeter. That gives me a context of how I should trust this data. I know they're coming from a person. I know it's from here or there, how it's measured. That means as this is just an example of pulse, but in other ways, if I know how the data is collected, in what context, with what kind of device, it will impact the way I trust the data transferred. So we believe that using expressions to properly define more abilities around the focus concept will actually be not represent data overflow as such, because the computers will handle that, but it will increase trust in data. And then from a technological or ontological perspective, these are the questions we ask to Snowman International staff, and we get a bit of a discussion. Do we actually need to give them unique identifiers, or is the string itself an identifier? Some systems handle it, some don't. Is there a need for classification of these expressions? Do they need to be pre-coordinated into a terminology to be proper analytics on, or can we just keep them as expressions without even classifying them? Should we then transform them to what's called the authoring form or the normal form to harvest all attributes and use an attribute search instead of an is-assumption? Those of you who were in the last presentation, Kylene as well, showed us is-assumptions. Then you need to classify, I think, because you need to make sure they're in the hierarchy. If you're just using the attributes and saying, give me everything that is a descendant of pulse, that is measured by a pulse oximeter, do we need to do that? We don't know. We're going to try it out. And that, of course, begs this last question, or last two questions. Should analysis be based on is-assumptions or attribute value pairs? How do you go about finding the correct data you're looking for? Or should they simply all be transformed to OWL2 before analysis and then using Sparkle? I'm not going to explain Sparkle because it's out of my league. That is what I had, Alejandro. If there are questions, my contact info is there. And I know some of our people are more than happy to give you a demo or how this actually is possible to make it work.
Thank you, Jørn. This is a great presentation. Jørn will now take questions. I will bring the microphone to anyone in the room. And the online assistants, feel free to write in the QA box. Any questions?
Thanks. A very, very interesting presentation. But what comes to my mind is that you are kind of recreating Loink. So how does your work align with the current state of harmonization between Loink and SNOMED?
I think the proper way to handle that harmonization is, like, I wasn't intentionally degrading Loink. I'm saying the magic value in this profile is actually not representing what we wanted. Heart rate it could. So the correct thing would be to say the magic value will represent, you know, this is heart rate. It is heart rate. Pulse is, maybe not for pulse, but I know this is what it represents. So you could align that with SNOMED at the same level in the hierarchy, but still you could allow SNOMED to add whatever attributes you want in addition. So in my world, my thinking, I would say the Loink value represents the category of information the way it is right now. It's more a closed world as it's used in Fire. I'm not saying Loink as a coding system is that, but the way it's used in Fire it is. And then use SNOMED to enrich the data and give more context around than the Loink code gives you.
That means in that particular case, you just had this very, very high-level Loink code pulse or heart rate, and what you were creating is actually not available in Loink.
Not that we could find.
Not that you could find. Okay. Yeah, then it makes sense.
But I think the Fire profile, to some extent, gives you a lot of that information in the model, and it can give you more of it in an extension. So, of course, you could build a model that contained everything. You could create your own code sets. That would lose a lot of the analytics possibility. because it's now no longer connected into SNOMED as a whole, and it closes your world.
Thank you.
Any other question?
So to be a resource of a vital sign, it has been decided, that's part of the standard, that you must have this heart rate loink code attached to it. That is a requirement. So we are just acting upon what is necessary. And I think that this is helpful because all the countries, and Norway is not one of those, who uses loink, they need to be able to communicate with people from areas where they do use loink. And if we could be tempting, throw out the loink code, then we will have a very different and more elaborate task of finding out what the meaning of this particular resource is. So this is trying to handle it in a way where it will give us that kind of semantic interoperability at that level that some people have decided it should be, and we would like to add all the things that we just declared.
Thank you. Our question? There.
Thank you. So I was curious, the FIRE model also has information model properties for things like devices and preconditions. And I was wondering what sort of principles or assumptions you were able to agree on or establish for determining what and when things belong in the information model versus the terminology model.
Simple answer is we haven't agreed. So our use case for this Oslo project was they wanted a very simple information model with a single code. And they said, we know where it's coming from anyway, so we're going to just use this. And as I said, with this semantic overlap, you could extend to having devices, you could precondition, you could do everything in loink, or as long as you extend enough, you could contain, but you would at some point be closing your overall. So this is more a proof of concept or a pilot to show this is how you could do it, containing information. You could choose to lose information through interoperability, just using the loink code, or you could contain as much as possible inside the expression. But it's a very important discussion to then discuss how does this affect the other elements of FIRE. When is the semantic overlap something you need to handle? And it's still to come.
Thank you. I will have to have a comment myself. It's incredible work. It's really good. I mean, given the restrictions of tooling that today AI for post-coordination, we are growing in the availability of different tools that allows you to store expressions, to classify expressions and everything. So I think that in the way you're using the web set for retrieving the expression, I think it's a very clever way. And it's very interesting. I think there's a place for classification here that would make this even better, because now you rely that the author of the post-coordinated expression chose the right focus concept, for example. But when you classify, maybe the concept rearranges to somewhere else, and you can get the benefit of the classification from there. But I think that the availability of terminology servers that will do these managed post coordinations and classify will happen this year. It's 2023, I think, is the year of the post coordination. So I look forward to seeing how this works. Thank you very much.
Thank you very much.